countdown. All right, welcome back. So our learning target for this video is writing functions, quadratic functions, specifically from a graph. So actually we're going to put a little twist on it. So we're going to get some graphs, we're going to get a table, and then we'll work out our three forms. So just an FYI, our three forms are standard form, which you have seen before. We're also going to do factored form, which you've seen but haven't quite written it in that form yet. And then also vertex form, which again, you've probably seen, but just use the table to input values and get the outputs for them. So those are the three forms we're going over. We're also going to write them down in our notes. And just remember to use your pause button, and then I'll put the after expectations up later. So I pre-wrote stuff so that you can pause. So title it, put a number on it for whatever page you are on. I put 4 boxes. We're doing 3 examples. So this is example 1. I'll pause later. Example 2. 3 will be a table. And then 4, this box is actually going to be a continuation from example 2. It's a specific piece of the mathematical problem. So I want to make sure you have enough room for it. So this is number 1. Please sketch a graph. Notice that the y-intercept is at 9. Y-intercept is at 9. We have 2 zeros. They are at -3 and +3. So pausing here. Number 2, when you're sketching this graph, notice the y-intercept, it's at -1, that's not the y-intercept, that's the vertex. The vertex is at -1, -8. And I have zeros at -3 and +1. So watch out for those important key features, characteristics of our graphs. And then number 3, this is our table. This is a 72, so -2 is the input, -72 is the output, -1 is the input, -45 is the output, 0, -24, 1, -9, 2, 0, 3, 3, 4, 0. And then this last one is vertex form specifically because from number 2 it's somewhat difficult to tell. Yes. I made that right. So we're good. Okay. So number 1 is first, and we're going to be finding this in as many forms as possible. So our first one I'm actually going to do is factored form. So factored form. I'm going to look at the 2 factors that we have. Because x is -3, that's a 0. I know that y is going to have a 0 at x -3. It's also going to have a 0 at +3. That was not a good x. And that's factored form. Boom! Done! Yeah! Okay, sometimes it's this slick. Other times you're going to see it stretch or compress, and there's going to be a GCF out in the front, and we're going to see that on number 2. But for this one, it is going to be just x -3, x +3. And one way to look at this is to know that when you have your parent function, you don't have to write this, but as you have your parent function of x squared, notice you'd have 0, 0, 1, 1, 1, 1, 2, 4, 2, 4. So if it's following that pattern of 1 squared, 1, 2 squared, 4, if it's following that same pattern, you know the GCF out front is just going to be a 1. It's difficult to tell in our notes when we're handwriting our graphs, but if you plug this into Desmos at the end, you'll see that these points all follow what this factored form is. Now, when I distribute this back out using the area model or your rainbows, you're going to end up with our standard form, which is why I've had you write everything in standard form. So this is y equals x squared, and it's actually going to be a special case. So it'll be x squared -9. That inside term of b will actually disappear. So that's my standard form. And then vertex form, I'm going to lightly introduce this here so you can see the pattern. You saw it before 2 notes ago when you described characteristics of graphs. So vertex form is y equals, and I'm going to have my scale factor in the front, so in this case it's just 1. I'm going to have x -0 squared plus 9. And this 0 and the 9 came from, you guessed it, the vertex. So if we look at our vertex up here, what's that coordinate? That coordinate is 0, 9. So the x value is always subtracted, just like point slope form where you subtracted inside with that x, even though it's actually positive. So it's x minus 0 squared and then positive 9. So do trust that 9 sign, that is positive, but then the 0 would be negative. You always subtract that value inside. And we'll see that more in the next two questions. So this is number 1, factored, standard, and vertex form for the exact same graph. When I say writing quadratic functions, sometimes there'll be a easier form to write it in. Most of the time, it'll be up to you which form you like best or which one works best for that question. All right, so then number 2, let's start with factored form. And if we look at our factors, we see that we have x minus 3, x plus 1. And I want to pause here, and I want you to think, why is it x minus 3? Why is it x plus 1? What tells me, wait, did I do that right? I don't think I did that right. Nope, I didn't do that right. And that's why I pause, because it's a common mistake. This should be x plus 3, x minus 1. It's always the opposite of what you think, because when we solve these, it's going to turn into x equals 1, and it'll turn into x equals negative 3. So eventually we're going to set each of these to 0. So if you have x plus 3 equals 0 off to the side, this would equal x is negative 3, and that is our root that we're looking for. So that's why it's always the opposite. Okay, so now that we have that mindset in, this one didn't matter because one's plus, one's negative, so it doesn't matter which one's which. But on this one, it does matter. That positive 3 tells me to go left 3. This negative 1 tells me to go right 1. Okay, and now if we look at it, this vertex of negative 1, 8, that's not going up 1. If I went over 1, up 1, or is it? It shouldn't be. It should be, yeah, okay. If I go over 1, I'm actually going up 2, and if I go over 2, I'm actually going up 8. So if we look at this, it's going to have a scale of 2. It's a little simpler to see if I was on actual graph paper. So notice that on a regular quadratic, if I go right 1, I go right 1, I go up 1. So it's 1, 1. If I go right 2, I go up 4, right? 1 squared is 1, 2 squared is 4. When I graph on this one, if I go right 1 and I go up 2, that's a change, 1 to 2. It's not 1 to 1. And then if I go right 2, I go up 8. So what could change a 1 to be a 2, 1 squared, and 2? Okay, I'm explaining this horribly. Okay, so, and that's why we're doing videos, so that you can pause this, you can think about it, you can bring questions to class, okay? If I was doing this in person in front of you, I'd be doing the exact same thinking process I'm doing right now. If you come up with something that stumps you, you pause, you look at it, and you focus. So, I know that I have to take 1, and I have to square it, and somehow I have to end up with a 2. That tells me that I have to multiply this by 2. I can test that. When I have 2 squared, that should end up with an 8. The only way 2 squared turns into an 8 is if you multiply it by another 2, because 2 squared is 4. 4 times 2 would be 8. All right, so that's where my 1 and 8, that's where I'm getting that GCF of 2 outside, and you can test it. And I'm going to show you in vertex form how we can prove that 2 exists. Okay, that's factored form. Standard form, standard, is the exact same thing, it's just distributed out. So we use the area model, distribute that 2 back through. We've done this for 2 units now, so this would be the same thing as x squared. So if I do this out to the side, I'm going to have x squared plus 2x minus 3. That's these two binomials multiplied. Now I distribute the 2 across, and I'll get 2x squared plus 4x minus 6. All right, that's standard form. My A is 2, my B is 4, my C is negative 6. And then vertex form we're going to do down here. So vertex form, I know that I'm going to have y equals something, x minus h squared plus k. And we're going to fill this in as we go. Now, The h is going to be the x value of my vertex. So my vertex is -1, 8. That means h is -1 and 8 is my k. So I'm going to rewrite this. I have y equals still something, x minus -1 squared plus 8. So I have everything except for one question mark. I need to keep the y and the x in there because it's a function. I need to figure out what that question mark is. So we can do this by substituting values, which we could use the vertex if we wanted to, because that should work, right? 8, 0, divided by, nope, I can't because that would make 0. I can't use the vertex. Okay, but I can use any other point. So what's another point from this graph that we know? You could use the factors if you wanted to. You could use like the y-intercept if you want. It doesn't matter. I'm going to use this point because why not? So -3, 0. That's the coordinate I'm using, -3, 0. Going back down here, wait for me to catch up. I'm going to use -3, 0. That means instead of y, I have 0. I still have the question mark. Instead of x, I put -3 plus 1, because if I subtract the negative, that's the same as adding a positive, squared plus 8. And now I just have to solve this equation. All right, so I want you to pause and actually solve this one on your own so you're not listening to me drone on and on, because you know how to solve an equation. I should have done it live. Okay, as in live as in kept playing for the recording. But I did something interesting. It's a really quick fix. You don't freak out. Don't erase anything. You're totally fine. But I did something interesting. What did I write incorrectly from the beginning? It's really small. It's a really small thing. Look back at your graph. I'm not going to move my paper. My vertex is -1, -8. Make sure you catch your negatives because that messed me all up. That should be -8 on my vertex form. So this should be -8. This should be -8. This should be -8. So I'm going to add it to the other side and get +8. So now question mark should equal 2. That is how we found the scale factor, or that GCF, to be 2. 2. So my vertex form, coming back up here, you can either rewrite it or just erase the question mark. This question mark turns into 2, and then put plus and plus. This is my vertex form. All right, 3. 3 goes pretty quick once you identify the pieces that you like and you need. Notice that vertexes are always going to be in the middle, so everything then falls down from that. Good question. I don't remember what this graph looked like, so I'm going to cheat and look at what it is. I was right! Woohoo! Yay! Okay, so vertexes are always in the middle, and quadratics are always symmetrical, right? Because we learned that from graphing. You always get the bonus point that goes on the either side. So, looking at number 3, what kind of important points are these? They're actually doubly important, but what kind of important points are these? So these are called my zeros, my roots, or solutions, or x-intercepts, and they give me factors. So this gives me, for sure, I know I have x minus 2 as a factor and x minus 4. All right. I don't know if there's a GCF yet, but I know for sure I have these two factors. I also know that they're symmetrical. So if I was going to sketch this, -2 is way down here, 2, 0, 4, 0, 3, 3, and I know it's starting way down here, so that has to be my graph because it has to come back down to hit my 0, and 3 is smack dab in the middle of 2 and 4, and vertices are smack dab in the middle of all my graphs. So I know this sketch is rough, but that will be my sketch. So knowing that, 3, 3, why is that important? It's my vertex, which means I can write vertex form. So I can write y equals something, x, my x is 3, so minus 3 squared, and my y is positive 3, so plus 3. Notice that I'm taking that vertex, I'm putting in the x value with the x, the y value goes outside, just like with point slope, and I have x minus 3 squared plus 3. I don't know if there's a scale factor, so I'm leaving that blank. And then standard form is just multiplying those all out once I get to it. So I can't do that one yet, but I'm now going to figure out using this method over here. So we have enough room. I have my vertex form. I have a question mark. I have other points I want to use. 2, 0. That's a nice small number. So let's try it. So instead of y, I have 0. And then I put a blank with a question mark. And instead of x, I put 2. 2 minus 3, 1. 1 squared, 1. So this goes to 1. So I just have 1 question mark. Subtract 3 the other side. So question mark is negative 3. If that confused you, rewind, go back and look at my algebra from over here in this box, and just replace the positive 1 and the negative 8 with negative 3 and positive 3. And then find the question mark using a coordinate. I used 2, 0. You can use any coordinate you want except for the vertex. And then over here I use negative 3, 0. So the scale factor is negative 3, and that means that if I distribute this all out, I should end up with y equals, okay, so that makes x squared minus 6x plus 8. So I get negative 3x squared minus 6x, so plus 18x plus 8 minus 24. That's my standard form. So sometimes standard form comes first, and most of the time it actually comes last because you have to distribute everything through. My lid went somewhere. There it is. Vertex form is the quickest. If you know the vertex, I kind of think factored form is the quickest because usually you know the factors, but sometimes factors are ugly numbers and your vertex is a nice number. It took me a while to find this example that had a vertex that was a nice number and that had factors that were nice numbers. So typically there's one form that works better than another, and that should be good. All right, so I know it went over 15 minutes. But it was good. Add some good problem solving in there. It was good pausing. I hope that you paused. And yeah, so remember, did you pause the video? Are you going to bring questions? Did you comment on the video down below? If you're in full screen, escape full screen, go down. And then, yeah, bring questions to class. Bring comments, please. I love hearing them and working through them with you. All right, have a great day. Bye.